go down by this side. Or tap the space key. Okay. So, good evening, everyone. And I think I'm audible enough. So, today I'll be presenting my idea on this title, that is influence of asymmetrical street design on thermal discomfort. And the most fundamental question is how I have started with this idea. So, India is fast-growing economy, and it is true that most of the cities are densely populated. Furthermore, those cities are rapidly expanding in terms of their urban footprint. These urban expansion also transform urban climate condition at every scale. However, conditions worsens human health risk at micro scale, resulting in extreme thermal discomfort. So there are numerous amount of studies which mention about the thermal discomfort medication. One basic idea behind all studies are the scale of mitigation, and it is very important to fix the scale of mitigation. So according to various studies, the major scales are it starts from UBL, that is boundary layer, to UCL, where UBL is mesoscale and UCL is microscale. So for our particular study, the highlighted area will be street level, that is UCL. And all we know that street are the fundamental elements, and it also accommodate the vital portion of outdoor. So, with regard to human thermophysical interaction, it is very important to conduct the thermal comfort studies. Okay. Now, after deciding the scale of our study, that is street level and macro scale, we have started our investigation on the availability of mitigation measures. So there are two established theories for mitigation measures. That is, one is preventive measures, one is corrective. Corrective measures are mostly adopted after project completions, and these are mostly consist of vegetation and green infrastructures. So for our study, we are not considering corrective measures. We are mostly focusing on preventive measures. And preventive measures are the measures those can be implemented before the actual design. So it's a pre-design phase. Okay, and this mostly consists of street configuration. And as we all know that from the many studies we have established, street microclimate conditions are the one of the outcomes of street configuration, that is street orientation and aspect ratio. Okay. So the concept of street configuration is usually represented by two significant parameters, that is aspect ratio and sky view factor. Furthermore, the classification of street aspect ratios are low and shallow aspect ratio, maybe high and deep aspect ratio, and they both have their own benefits. These aspect ratio have both benefits. Like high aspect ratio are good in shielding the radiation, like main radiation or outdoor radiation, and some of the studies says that low aspect ratio are good in enhancing the wind movement. So both have their own benefits, but there is one more condition, and which is mostly ignored in older studies. That is one condition called symmetricity and asymmetricity. So the condition of symmetrical and asymmetrical street canyon are based on equal or unequal variation of structures and width of the approach road. Actually, the symmetrical street we can say actually the symmetrical street aspect ratio does not reflect the actual conditions, actual variation in building typologies, especially in Indian cities where the urban fabric is not uniform or not homogeneous in nature. For the purpose of thermal comfort assessment, this study considers the evaluation of microclimatic parameters in two stages. So the first stage is about air temperature, relative humidity, and wind movement. And the second stage is about to evaluate the human-centric analysis. That is the reason we are going to conduct our study through by using thermal index, that is called UTCI, Universal Thermal Comfort Index. In conclusion, the study will display the results in through three variables, that is air temperature, second will be mean radiant temperature, and third will be UTCI, Universal Thermal Comfort Index. So our associated task will be, first task will be categorization of streets and its interoperability with the available guidelines for the cities with the morphological attributes. And the second will be prioritization of hotspots and mitigation strategies. So the methodology will follow. It will be categorization of street, the first. So the first phase will follow the existing orientation, that is east-west orientation, and we will iterate it. We will give the iteration for the next orientation, that is 45 degree from the east-west and then 90 degree from the east-west. And the second will be based on aspect ratio, that is high and deep aspect ratio with the symmetrical and asymmetrical conditions. So these are the mapping of input and output data. So the above is the output data where we will follow the shadow analysis and SBF analysis, followed by air temperature and MRT, and then third will be UTCI. And this is about the study area. The site is located in the center of India, that is Bhopal, and it has very close proximity to Tropic of Cancer. Weather is mostly hot and dry, and we can say, according to ECBC, that is Energy Code, Building Code established in India, the weather is composite in nature, and we have done the first cross-checking with the available guidelines. So these are the two guidelines I have referred. First is URDPFI guidelines, and the one is Indian Road Congress. So this gives us the physical nature of and the physical classification of the Indian roads, what we have. So according to these classifications, we have selected two streets. One is major streets. This can be shown in the highlighted one. So major street, and the second is the local street. So further, the dimension of the major street and local streets are marked there. So major street is 18-meter wide and the local street is 9-meter wide with the pedestrian pathway and regular way. This is the about the input of simulation data. We have used simulation, environment simulation. So input for selection of date, we haven't considered the solstice, summer solstice or June month for the peak summer period. We have considered the history data, weather file from the recent weather file from Indian Meteorological Department, and then we have fixed for summer discomfort period. We have fixed April month, and for the winter discomfort period, we have fixed the December month. Okay, this is the hypothetical framework we have generated. So this framework followed three-step classification. The first step is the classification of main street and local street. Okay, and the second classification is low and high aspect ratio. There are total 5 aspect ratio. 2 are low and 3 are high. We can see in this presented table. And the third is symmetrical and asymmetrical aspect ratio. That is 3 asymmetrical and 2 symmetrical. So this is the overall hypothetical framework, how it will work. So this will be followed by different orientation with vertical strata will be showing main street and local street configurations. This is about the environment result, and I'll directly go to this base case where I have tabulated all the data according to the timeline. So the major remarks are higher sections always perform better than lower sections. Lower sections perform same as irrespective of asymmetricity and symmetricity. Higher asymmetrical section is in local state is not best option. Even it has highest aspect ratio. Higher asymmetrical never perform worst, while but always perform next to best. And coming to the iterated scenario, this is the seasonal tabulation I have done. This is the first iteration with the clockwise direction, clockwise orientation of 45 degree, and this data show the summer and winter season variation of temperature, relative humidity, MRT, and UTCI. And this is the last iteration of orientation, that is 90 degree from the base case. So this is the final outcome on different orientations. So the thermal variables plotted on the different orientation, and major remarks we have concluded is north-south direction, that is the last direction, that is the third one, is the best and most efficient one because it has ability to decrease TA, MRT, and UTCI or almost from all over the time from morning to evening. And then northeast southwest direction, that is 45 degree from the clockwise direction, it shows the most fluctuation in TA and MRT results. And within the northeast and southwest orientation that show the most fluctuation, higher symmetrical street, that is the asymmetrical street, showed the most fluctuation. Then we have plotted same data with respect to air temperature, mean radiant temperature in UTCI. So there we can see with the timeline. I'll I'll give you the results. So there we can see there are two kinds of fluctuation we can see with the northeast and southwest. So one fluctuation is uh, about within the thermal variables, that is air temperature and mean radiant temperature. So sometimes air temperature is increasing in the morning, but mean radiant temperature is decreasing. So it shows that urban canyon plays an important role, and especially the asymmetrical urban canyon, which are opened from north and south. So in conclusion, I'll be concluding this with first conclusion is India is going to see the rapid development in future years. So we need a more morphology based possibilities for new development projects, especially these morphology can be adopted with the symmetrical aspect ratio consideration. And the second could be perhaps the asymmetrical streets are the most efficient approach, which can actually shield the solar radiation, and the same time it can enhance the wind moment also, which could not be possible in the case of symmetrical streets, where those solution of symmetrical streets are only unilateral. So yeah, so symmetrical streets always have benefits either of shielding the radiation or it can enhance the wind movement. But a symmetrical street has this possibilities of both. So thank you.